All right, guys, so in this video, we are looking at another characteristic of right triangles, and those are the trig ratios. Now, these ratios are a number. Remember, a ratio is just when you're comparing two things. And what we are doing is we are taking an angle of a triangle. So in this case, I've got this triangle over here on the right. It's a 90-degree triangle. It's a right triangle. And we are looking at angle A right here. Now, my trig ratios are unique to this angle A, all right? So this angle A has its own set of trig ratios, of comparisons that we use. And what we use for those comparisons are the sides of the triangle. So if this is my angle A, the first thing that I want to do is label the sides of my triangle. Now, across from my angle A, that side we call the opposite side, all right? Now, across from the 90-degree angle, that side is always called the hypotenuse. And that leaves one left over. This side down here that's connected to A, that is called the adjacent side, all right? Now, if I were looking at angle B, I would have different opposite and adjacent sides. These opposite and adjacents are related to angle A. So the three ratios that we are interested in are called sine, whoops, if I could spell right. We're looking at sine, cosine, and tangent. Now, the way that I write these ratios is after I write sine, I can't just start writing the ratio because its sine is a special ratio of a certain angle. So I would say that the sine of angle A is equal to the opposite side divided by the hypotenuse, okay? So the special ratio for sine is opposite over hypotenuse. The cosine of that angle is the adjacent side over the hypotenuse. And the tangent of my angle A is equal to the opposite over the adjacent. Now what's cool about these values, for example, let's say that angle A, let's give it a value. Let's call it 30 degrees. So this becomes the sine of 30 degrees is equal to something. That something is always the same ratio. It will always be 1/2, which means that your opposite side is always going to be half of the hypotenuse, which is kind of a cool characteristic. It doesn't matter how big my triangle is. If I have an angle of 30 degrees, the opposite side is going to be half of the hypotenuse. That's a really powerful tool that you can use in problem solving. So the first thing that you need to worry about is remembering these three trig ratios. They are something that you are going to have to memorize. This is going to come up on every test you take in the future, whether it's the ACT, the SAT, a college placement, the MCATs, any placement test is going to include this. It will show up, I can promise you that. So it's really important that you memorize these ratios. And there's a couple of things I'll share with you that might help. I don't care how you memorize them, you just need to memorize them. The first one is this phrase right here. And it says SOHCAHTOA, okay? If you go home and ask your parents, what does SOHCAHTOA mean? They probably will tell you what it means because they remember it. It's one of those things that sticks with you. Now, the way that you use SOHCAHTOA, S stands for sine, and then the O, so, stands for what goes after the sine, the opposite over hypotenuse. For the ka, SOHCA starts with a C, so that's my cosine, and then it is followed with an A and an H, so that tells me adjacent over hypotenuse. The TOA starts with a T, so that tells me tangent is opposite over adjacent. So that phrase, SOHCAHTOA, might help you remember these ratios. That's one way to do it. My favorite is one that actually Mr. Goodrich taught me a long, long time ago, back when I was in high school. And the way that he remembers SOHCAHTOA is he came up with, I don't even know what it's called in language arts, but he assigned a different word for each letter. So instead of SOHCAHTOA, what he says is that some old hippie caught another hippie taking old acid. Okay, so this one, I think this stands out because some old hippie caught a hippie taking old acid. That is a phrase that is going to stick with you for a little while, and it always made us chuckle back in high school. So same thing. The some old hippie tells me sine is opposite over hypotenuse, SOH. Some old hippie caught another hippie. Cosine is adjacent over hypotenuse. Taking old acid, TOA. Tangent is opposite over adjacent. All right? You come up with your way of memorizing these, but there's two that we've used in the past that seem to work pretty well. Now, to do math with this, the first two problems, all it wants you to do is to write the ratios. You don't have to solve anything. It just is saying, for the angle M, write the ratio for sine, cosine, and tangent. So the first thing I'm going to do is label my triangle. Across from the 90 degrees is my hypotenuse. Across from the M is my opposite, and next to the M is my adjacent. Now it wants me to write my ratios. So the sine of M is equal to, sine is opposite over hypotenuse, so that is 7 over 25. The cosine of M is adjacent over hypotenuse. Adjacent is 24, hypotenuse is 25. The tangent of M is opposite over adjacent, so 7 over 24. Those are my ratios. If it wants you to just write the ratios, that's all you would have to write. The second one we're going to go through really quick because you can actually simplify some of this. Again, I'm using angle M, so I'm going to label my triangle. Across from the 90, that's my hypotenuse. Across from my angle is my opposite. And next to my angle is my adjacent. So the sine of my angle M, I can't just put sine, I've got to put the angle it goes with. The sine of my angle M is equal to the opposite, so 2 root 3 divided by the hypotenuse, which is 4. And that simplifies. 2 over 4, that's just 1/2. So that becomes 1 root 3 over 2, which is just root 3 over 2. Same thing, right? Cosine of M is adjacent over hypotenuse. Well, adjacent is 2. Hypotenuse is 4. So that means my cosine is 1/2, which means that my angle is actually 60 degrees. We'll do that in another class. Tangent of M. My tangent is opposite over adjacent. So 2 root 3 over adjacent, which is 2. So those cancel, and I'm just left with root 3 as my answer. All right? So what we do in this class is more than just write the ratio. On a lot of the tests that you do in the future, it might just want you to write the ratio or to find it. We are going to use this special ratio to help us solve missing sides of the triangle. So I have a triangle right here, and it gives me this angle, 54 degrees, and it wants me to find W. So I am going to label my triangle first of all. So across from the 90, there's my hypotenuse. Across from my angle, that's the W, that's my opposite side. And next to the 54-degree angle, that's my adjacent, all right? So I've labeled my side. Now I'm trying to solve for W, which is my opposite side. And I know the hypotenuse. So what I want to do is find the trig ratio that uses opposite and hypotenuse, which is sine. So here's what I'm going to write on my paper. Sine of my angle, 54. I can't just put sine, I've got to put the angle after it. Sine of 54 is equal to the opposite, which is W, divided by the hypotenuse, which is 17. From here, you know how to solve the problem. It's just railroad tracks. You times both sides by 17. Please put the 17 before the sine. So you're going to put 17 sine 54 equals W. I don't have the sine of 54 memorized, and I don't need to have it memorized because it's in my calculator. If I go to my calculator and I type in 17 sine, it's a button right there above the 7, and then I'm going to put a 54. Now, before I hit enter, I need to double check. I need to go to mode, and I need to make sure my third option right here says radians in degrees. You need to make sure you are in degree mode, otherwise it's going to give you the wrong answer. So 17 sine of 54, when I hit enter, I get 13.75. So that means W is 13.75. Is that what I said? I don't even remember. 13.75, yeah. All right, that looks good to me. 13.75 is my W. So let's try a couple more. I've got a W, I've got an angle, and I've got a 1. So here's my angle that I'm using. First thing I'm going to do is label my triangle. Across from the 90 is the hypotenuse. Across from my angle is the opposite. Next to it is adjacent. So this tells me I am looking for the adjacent and I know the opposite. So I want to use something that uses opposite and adjacent, which is tangent. So what I'm going to write is the tangent of my angle, which is 28 degrees, is equal to the opposite, which is 1, divided by the adjacent, which is W. And now I've got to do my railroad tracks, which some of you haven't done a lot with W on the bottom. We treat it just like a number. I want to get W alone, but right now it's on the bottom, so I've got to multiply both sides times W. So I get W tangent 28 equals 1. Now I've got W multiplied by the tangent of 28. Well, the opposite of multiplying is dividing by the tangent of 28. So I'm going to divide by the tangent of 28, both sides. So that gives me W equals 1 divided by the tangent of 28. So if I go to my calculator, 1 divided by tangent is right above the 9, 28 degrees, enter, is 1.88. So I get W equals 1.88, which seems reasonable. If my short side is 1, W's 1.88. That seems like a reasonable answer to me. Okay, last example. It gives me a W, it gives me an angle, and it gives me another side. So let's label across from the 90 is the hypotenuse. Across from my 33, this is the angle that I'm using. Across from the 33, I call the opposite, and that means W is the adjacent. So I'm looking for adjacent, and I know hypotenuse. So adjacent and hypotenuse, that gives me cosine. So the cosine of my angle, 33 degrees, equals the adjacent W divided by the hypotenuse, 4.5. So now when I railroad track, I just multiply both sides by 4.5. Remember, put it in front, please. 4.5 cosine 33 equals W. So I go to my calculator, 4.5 cosine of 33, enter, I get 3.77. So W is equal to 3.77, which seems reasonable, right? It seems like that is a reasonable answer for W.